तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
We were looking into the implementation of real time clock using Verilog. We will continue the same. We have before this we have seen how to declare the various signals, and right now we are about to start with the real time clock implementation from Kia. So, as pointed before, we have a decimillisecond register which is to keep track of 0.1 millisecond, and this is the basic time base provided by this counter going by this name Contd DMS, and whatever is a register, for that matter even a counter is a register, and it is with this symbol here underscore reg. And to start with, we have put a advanced increment here, which is, this is the actual register. The incremented value is put in this, and it will be reckoned only when the positive edge of the clock strikes, and that is done here with an always block which you are already familiar with, and we have the block commencing here, and this is for the reset condition, and whenever system reset is encountered, you need to reset this particular running counter, which is 13 bits in width, and look at the comment which is plain. And next is, if this is satisfied, it does this operation, otherwise it takes this, and if it finds a match, that is when the running counter, which is counter DMS, DMS means decimillisecond. So, when this counter equals the set value, we have set this before right in the beginning by defining, and when it matches with this, and what you need to do is reset the counter once again, and otherwise what you need to do is increment the counter. So, that is what we are doing here, but this incrementing we have done before by using an assign statement, which is advanced pre increment, and thus this counter is complete. And similarly, we have very many counters to do time in decisecond, that means 0.1 second time base. This is exactly same as that one, except that the signals are different. For example, counter decisecond next will be the advanced increment for the actual counter, which is Contd ds underscore reg, and once again this is the always block for doing this incrementing, resetting, and when the time meets the set value such as ds base, it has to reset again, and note that this counter is 23 bits in width. Otherwise, what we need to do is assign the pre-increment value to the counter register, and once again we have one more register, which is a 1 second time base register or rather a counter, which is being taken only if this condition is met. For example, TB second implies that when this running counter is equal to the set time base, for example, we have set I think 9 to give a 9 second, then when it matches, and also it matches with decisecond, that is 0.1 second, this is to get a more accurate timing. otherwise what will happen for this value multiple times this will be encountered. We want to service only once, the very first time it encounters, therefore we have included this as well. And we have as usual a pre increment of the same register, and then the actual register takes place here, again reset, and when time based second, just now we have seen the condition, when it is 1 second, at every 1 second we have to take this action. What all you should do is just reset that counter, running counter. So the counter is incremented in the next step when the counter time base is 0.1 second. So and that is what you have to do. That means you have to advance this particular counter every 0.1 second, and that is what we are doing here. And for debouncing, we have another counter which is running called debounce counter, and this is the condition that we want to take action. For example, we want decimillisecond, let us say we have one more signal, and when the debounce counter is equal to the set debounce time. For example, we have, if you remember right, it is 29 that we set, corresponding to 29 into 0.1 millisecond. Decimillisecond is also to be reckoned with together for the same reason that we have seen for the earlier ones, and that means to say 29 into 0.1 millisecond, that is 3 millisecond. 29 is actually to be read as 30 because actually 30 clocks are involved, although you set at 29. It is because we start counting right from 0, 1, 2, 3, 29 all inclusive is 30 actually. So 30 into 0.1 millisecond would give you 3 millisecond. That is how you get a 3 millisecond debounce time. That means whenever a switch is pressed, it will make and break for some time, say 2 to 2.5 millisecond based on real time experience. And in order to get rid of this movements, oscillations, we want it to give some cushion, some time delay, so that we sense only the steady state. So for example, you push a button, it will make and break for a while and then settle down finally, because your pressure that you have applied on the button is much greater than its kicking back and breaking the contact. And that is what we mean by the debounce time, which you are already familiar with the previous lectures that you had seen. And here we need to once again pre-increment this debounce counter, and once again we reset when system reset is encountered, and if a decimillisecond, that is after 3 millisecond delay, we want to reset the same counter once again, and that is how it keeps on going from 0 to 3 millisecond and revolves around that. And every time the clock strikes, which will be at every if it is 20 megahertz, every 50 nanosecond the clock will be arriving. At every clock second this is going to take place, and although we have seen several always block, it implies that they are all parallel circuits. It is not a sequential circuit, as I have been impressing time and again. And when the counted DMS, that is a 0.1 second time base, is actually 0.1 millisecond, but we are going to check for 30, 29 is setting value here. So that means it gives 3 millisecond, and when I am sorry, this is only 0.1 second. When advance the count once every 0.1 second, because we are trying to advance here, this is resetting only will take 3 millisecond, whereas advancing you have to do every 0.1 second. I am afraid that is some I think it is 0.1 millisecond, I am sorry, that is a mistake there. So 0.1 into 29 is 30, so 30 into 0.1 is 3 millisecond. In order to get 3 millisecond here, right, we are going to advance 30 times. The incrementing will take place only here because of this pre-increment test done before, and that incremented value is assigned here, and this assignment takes place only once in 0.1 millisecond, and there was a mistake there, please correct that. I have corrected the same here. And next block is for we need to take action for different switches that we have seen in the layout earlier. Run set was one such and time stopwatch, down, up count, all were there earlier, and I said that we will have to read that one and preserve it as a register, and that is why the, OR has been used. And whenever you reset, these are all the signals, rather they are all flip flops fundamentally in the hardware, and we need to reset them whenever you apply power on reset. Right at the starting of the system, you need to reset them, and that is why all these signals right up to hours, minutes, seconds, start, stop, all these are registers basically, including alarm, off, on, read, set, and for the 3 alarms, and all of them need to be set to either 0 or 1 as the case may be, depending upon what is active or what is inactive. It should be inactive at this point of time, and so is the case for run set, which we are going to use after debouncing. That this has also been explained earlier, and these are all the ones which is true reflection of your actual input, corresponding inputs here, and there is a run, set, as well as time stopwatch, then up, down, then hours, minutes, seconds, start, stopwatch. All this this stop n implies if this is 0, it means in stop. So right now it has been initialized to stop condition. You can advance up counter or down counter only if start stop is in stop mode, that means when it is 1. So to start with, we are right now in the reset mode, and that is why we need to stop the thing to start with, so that when you switch on the system, it won't start running automatically. It will run only when you push the button, start button. And similarly, alarm off on switch also has been taken to off position. Off is 1 here, that is why it is. Similarly, this read, alarm, read, set has been put in read mode, not in set mode. And similarly, alarm 1 through 3, they are all taken to active low, that means they are not set. So only 0 will set in this condition here. And next step what we had to do is the actual working starts right from here. So the work starts for changing different signals in accordance with what is really happening. For example, this run set switch is being read here and assigned to this register only at this point when the clock strikes, and also when this condition is met. For example, this condition is debounce counter must be 0, that is to say we are just starting. What we need to do is to debounce a particular switch, either a push button switch or any other switch. This can be done only by reading the input first right at the 0 time, that is what is implied here, both mean 0 time, and then read from the actual input. I stands for the input, which we have already seen in the simplified architecture, and assign that to the register, and that is what is R here. And so is the case for time and stopwatch, then up, down, then the 3 push buttons, and start, stop also. This is also a push button switch whose status we will have to keep track of. These are all the registered conditions of the actual input here. And for alarm off on, once again these registers, and 3 alarms are there, all registers here. It is precisely same as input, but we are registering here only when at the time of 0 that we have already set, seen before, and when the clock strikes, which will happen at every 50 nanosecond if it is a 20 megahertz oscillator. And if that is not satisfied, next thing is it may satisfy this condition. This condition is debounce counter equal to debounce time. So that is debounce time is 3 millisecond we have seen. So when it is 3 millisecond, then what action should we take? So this is not only reckoned with this, but also we see with reference to a decimillisecond also. It is to have a finer tuning, and it should happen at precisely this time when it is ripe, and not subsequent times. So this condition may be met for several conditions of this, but first encounter that we have here, for that only we need to take action. That is why this also has been taken into account. Normally designers ignore this and get into trouble later on when they do not reckon finer timing, etc. And next is when this condition is met, what we need to do is the actual debouncing of the push button switches or any other switch. This is done by if you take let us say we have not pushed a button. So it may when you read it, it may read say a 0 state, and if you push a button, it may read a 1 state. So how will you sense that transition, that it has been just pushed? It is this particular thing which gives that intelligence which reckons the pushing of the button. So this can be very easily done. Suppose the previous value is, this one is the present value of this push button, and R run was the previous value we have just now seen in the previous else condition, and that is the this is nothing other than the same condition, but in the previous clock and when 0.1 second or whatever time base that matches has been met. So now when the subsequent sample, that is the current time now, suppose the push button has been pressed in between, suppose 0.1 second back it was 0, that means this was 0, and now in between after 0.1 second this is going to be read. In between whatever be the time when it this goes high, it will be reckoned only at a 0.1 second now. It may not be really 0.1 second, but here it is as per as I think debounce time, 3 millisecond delay. The first sample is this R run, and the second sample is the present value here. So the time lag between these two is 3 millisecond, and that is how you are giving the debounce time of 3 millisecond. When you AND this together, if both are 1, then you can say that with confidence that push button has been pressed previously. Before 3 millisecond it was already pressed, and now it is continuing to be in the pressed condition. That is how you recognize that. So is the case for all other things, for example time, stopwatch, down, up, and these are all the signal names given for this debounce logic operator upon. And the logic for hours, minutes, seconds is slightly different, because this is basically these are all active high signal, and that is why we have used ANDing. If it is active low signal, we need to use OR, and since we want that particular pressing of the button to be recognized as 1 for further processing, if you want it as 0, you are free to do so. I have chosen to make it as 1 active high. This signal is active high. If you want this active high, note that we need to OR the present one, and this is the previous value of the push button. So when both are same, for example if it is both are 0 0, that means it has been pressed 3 millisecond prior to this, 3 millisecond or more prior to this. That means when you press this push button is 0, not 1. So if it is previous value is 0 and present value is 0, the ORing of this one will be 0, and not 0 is 1. So that means the two samples have been reflecting that a push button has been pressed. This is how you debounce. So is the case for minutes and seconds push button, and so also the case for start and stop, and that is precisely the same condition that you have here. So start stop, the comment says start stop N, 1 means button is pressed, push button has been pressed for start, and we will have to deal with this little more in depth, and as we go on we will see more about this. And for alarm off on switch also you need to do this, but in this case I am treating it as active high signal, therefore I have ANDed the two, present past and the present. So is the case for alarm read set switch, which is right there on the front panel of the real time clock. And for alarm 1 through 3, you again these are all active low, and that is the reason why NOR has been used for the present and past samples. This always block is complete, and it has serviced all the inputs and assigned it, debounced it, and then preserved in the respective variables, which is exactly the same as the layout nomenclature that we have adopted earlier. And here starts the actual running time counting, and for this purpose we need 6 counters, counter 1 through counter 6 underscore reg, of course. So is the time watches, there is a mistake here, you can just correct, I think watch E must not come there, right. Time watch most significant, our digit is counter 1, and LSD is counter 2, and this is reset or advanced only in the run and time mode of operation. This is obvious, and because we want only the running of the time, and we have another signal called run time, which precisely reflects what mode this is in. So when run set switch is in 1, which means if it is 1 it means run, if it is 0 it means set, that is why the n is given here. So is the case for any other variable, for example time stopwatch, it is in time mode because it is 1. So it means run time. So this logic is assigned to a single variable called runtime. So that that is the reason why we had several wire declaration. I think that was your question offline, and that is the reason why we had done. If you can easily keep track of logic pertaining to a particular state. So for example runtime has been kept like this, so that you do not have to put the same logic again and again later on. In order to avoid that one, we just assign it to some other signal and use that particular signal which is a meaningful name. Runtime is for as for example. And next thing is set time. It has exactly same meaning. What you read, so it is. You can just verify for yourself. For example, set is 0, then time is 1. Okay, set time. That's what we have given here. And set alarm must be in 0 condition because we don't want to set the alarm. Is that the right thing? Okay. Then set time and set stopwatch modes respectively. This is exactly the counterpart of this, and you can just reason out yourself. And similarly run stopwatch set alarm, you can once again see here, run is 1, then time stopwatch is 0. Okay, so it is run stopwatch. That's how we have got here. Set alarm, once again you can see. So it has been is 0, so it reads set here, and this is alarm, right. So if it is not in step set stopwatch, stopwatch is one thing, alarm is for the time. So if it is not if it is set stopwatch, then you want to have this is for alarm setting, right. So is this right, set or read alarm in set stopwatch mode, that is what it means. So here we have some 3 statements that is going to follow, and it is for hours, minutes and seconds. Push buttons are pressed or sensed 0.1 second, clock tick if the push buttons are kept pressed for 2 seconds or more. This was the question addressed earlier by one of you last time. So what we do is, every time we want to set something, we can either go into auto mode, wherein the system looks for 2 seconds a key push button being pressed, then it runs very fast, so that large delays can be easily set because it is running faster. If you close in, you can release the button and advance slowly by pressing push button each time you want to count just 1, and that is what it means here. And this is for following statement, since when the hours, minutes, seconds push buttons are pressed, or sense no senses, or sense 0.1 second clock tick if the push buttons are kept pressed for 2 seconds or more. So this is clear, I hope, precisely your doubt. Okay. And we also said we needed 2 seconds on delay timer. For that we are using this signal called hours underscore d. D stands for delay. Okay. So or if you want, you can say on delay. Okay. On delay means when you close a switch, the timing starts, but the output is not at energized. Only after the expiry of 2 seconds the output goes high and remains like that. That is what is known as on delay timer. And we require that. Why it is required, we will see when we come to the appropriate point. So next signal is advance hours. Once again exactly the same logic we are putting here. Say hours is the push button that we have pressed when it is debounce condition, of course. Hereafter it is going to be debounce condition, and how we arrived at we have already examined. And when hours push button is pressed, then it will be 1, right. And the previous same signal, what is the previous value? So if you see that one, and if it is 0, then you recognize that a push button has been pressed. So present value is 1 and the previous same switch previous value is 0. That implies that a push button has been just pressed, right. So when that happens, or this happens, for example the delay, right, 2 second delay is going to come. How this 0.1 single increment, how it is incremented in a single manner, whenever you push a push button. For example, you push the button, it will go to 1 here, and earlier previous value would be 0 because you have just now pressed and it has been just now recognized, right. So it would whenever you make a single push button press and release, this will come into force, whereas if you keep it pressed for 2 seconds or more, this statement will come into play. So when this comes into play, then this delay will go 1 only after 2 seconds. That is how this circuit is working. Are you clear about it? So, why that was your question. So, this will remain for 0 for 2 seconds and then go 1. So, this will happen only had you press the button for 2 seconds or more. Had you released in between, this would have taken effect once, because this will be met when you push the button, this will be met, when you release it is not met. So, it is reckoned as just one push. That is how you can advance the hours either at one time, one advance, one count, or it can be a continuous count at 10 times the rate. How 10 times the rate is coming is because we are comparing with counter decisecond register with the decisecond base we have already set in. DS stands for the decisecond, so 0.1 second. So, this one will be as fast as you press. If you are slow in pressing, and it will advance only keeping in pace with your pressing, right. You can leisurely press any amount of time you can take. Whereas in this auto mode, it will be rapidly pressed, because this 0.1 second will keep on arriving ad infinitum. So, this will be multiple, but this will take into effect only if hours 2 seconds have elapsed and this has gone high, and so long as it is high, that long this will keep on continuing. So, this is how we do that. And if you, as I mentioned, such as Philips radio, if you see that one, precisely something like this they have implemented. So, that setting can be either manual one after another and or high speed, right. Exactly same argument holds good for advanced minutes and advanced seconds. I am not going into the detail, exactly the same thing, except that the signals are different. Similarly, you have advanced hours time. So, that means the same advanced hours we have already seen, that together with set time. We are also in set time mode, this also we have examined. When these two conditions are met, we call that particular signal condition as advanced hours time, right. Similarly, advanced hours stopwatch, advanced hours terminal count register for up count mode. So, what we mean by terminal count register is, in up count mode it is capable of counting up right from 0, 0, 1, 2, 3 etc. it will go. When we look at the demo after a lecture or two, you will understand it better, but right now this is sufficient, I hope. And as it advances, it will finally reach this set value. You can set this any up count value you can set by using those switches we have already seen, and I have explained in answer to your question last time. And when it matches with that one, so then a terminal count register, I mean it is a match here, right. Count register up count mode, it is to just signal that it is in advanced hours terminal count register mode, okay. And you can see here down up is 0, so it is in up mode, and it is set stop watch. It is there is no n, notice that, and do not confuse with that one, as I used to get confused while developing this code, right. So, set stopwatch is a single meaning. You are going to set the stopwatch, that is the meaning there. Do not take it as 0 stands for stopwatch, okay. So, what all this means is, it is in advanced hours step stopwatch mode in up count mode, that is what the whole thing means, right. And similarly, advanced minutes time and advanced minutes stopwatch, all these are self explanatory. Again, advanced minutes TCR, just like you had hours. Similarly, you are going to have for seconds right here, and I do not have to go into that detail. And next is, you have advanced hours, this is temporary alarm. This temporary alarm is there in order to set 3 different alarms, but before we set, we need some register for setting in a temporary manner, so that we will not overwrite our up down counter, because the same setting has been used for up counter, down counter, as well as for the 3 different alarm settings. So, quite many settings are there, so we will have to distinguish, that is why so many signals are there. And this is precisely for minutes and seconds as well, this is self explanatory. And next is, we have what is called display underscore alarm. In simplified architecture, we have seen this is what I had shown there, and what all it means is, you want to display just the alarm you want to set or read the alarm back, okay. You have 3 different alarms, for example, alarm 1, 2 and 3. if you if one of them is set, this basically a debounce switch. There are 3 switches for alarm 1, 3, I alarm, etc. This is nothing other than a debounced input, right? And 3 different, if any of these alarms are set, even if one alarm is set, one or more, and if alarm read set is in one condition, so what is to be done? So it is nothing other than display the alarm. We want to just display the alarm, that is what here. And if you want to display time, you see that it is time or stopwatch. Now you see that N stands for low, so it is not in stopwatch but in time mode. This 1 corresponds to time, right, and it is still in same display alarm has been used here, and that is the reason why otherwise the logic becomes too long, that it will be pretty difficult for you to keep track of the same. That is why signals have been separately defined, and display alarm must not be energized, right. So this is obvious. When you want to display the alarm, it should not display time, that is the implication there. So make sure that it is not there, and set alarm also must be 0. So because you are interested only in time, not the alarm or display the alarm. Either you want to set the alarm or display alarm, you do not want to do any of this, but you want to have only when time is encountered. So similarly for stopwatch, display stopwatch is there, time stopwatch here, this is stopwatch is 0. So this stopwatch mode, display alarm must not be there, set alarm also is similar to this, and only one of the 3 displays, alarm, time, stopwatch, is possible at one time. That is what I explained before too. And now the logic for the very first counter. So we need to reset the counter. At what time we would like to reset? I will read the comment first, so that you will get a grasp, and then we will explain the logic there. So it is nothing more than assign statements and always block that we are going to use. So it is quite easy to follow, although it is like a labyrinth. You have to look into all aspects, especially this will be a little tiring, but you have to do if you really want, interested in the working hardware, right. So you have to take care for everything, even a single mistake it will go totally out of order. And counter 1 through counter 6 is designated for real time and display, and the time that you can have maximum is 23 hours 59 minutes and 59 seconds. It is in time run mode. For counter 1 to 2, that is must be 23 in hours time set mode is the condition for resetting this counter. That means you want this time, for example, if it is this time, what you have to look for is counter 1 and 2 must be 2, 3. It is exactly same, counter 1 is 2, counter 2 is 3, and so on. And this is the condition for resetting this first counter alone. Counter 1 is this corresponding to. When do you want to reset? After 23, 59, 59 run time, what is the next time? It is going to be 0, 0. In other words, counter 1 is going to be reset, that is after 2 it has to become 0. That is what we mean here. So is it clear? And if let us see the actual logic here. For example, set time is not equal to 1. That means what? It should not be in the setting mode, but it must be in the run mode, then only it should take action. And it should be 1 second now. Every 1 second or 0.1 second there is always a clock ticking running all the time, and when it is 1 second, exact 1 second, then only you take the action, otherwise no. And counter 1 reg must be 2, that is the condition what we have put. This is coming right from this condition. And then counter 3 must be 3. Similarly other counters must be 5, 9, that is why you have 5 here, then 9 here, the counter 5, counter 6, 5, 9. So the whole thing is actually reflecting the comment that we have put here. Now this is one option, and another option is also there. This is while the timer is running, but what do you have not taken care for setting, right. So in order to do the setting, you have to take that logic also into account, and that is being done here. So for example, counter 1 is earmarked only for the hours, MSD rather, but when you want to advance the while setting, you are going to do MSD LSD together. LSD starts first, right. So it must be in advance hours time, which whose logic we have already seen earlier, a big logic expression earlier, and that must be ripe, and also counter 1 and 2 must be 23. So what is happening when you want to set auto setting after 23, what is it you expect? It should become 0, 0, right. So, but we are concerned with only counter 1. So, as far as counter 1 is concerned, after 23 you do not bother about 59, that is only in setting the run time during the time being run, whereas now we are bothered about setting the hours display alone. For hours you do not have to bother about minutes and seconds, that is why we are stopping right here. So, this statement stops just with 2 counters, because we are vitally interested only in the setting of the 2-digit hours. Same is the case for advancing the counter here, exactly the same thing, and here it is slightly different. I will just read out the comments hereafter, so that you can easily make it out. Everything will be precisely in the same fashion, you can easily make it out. I am going to read only the comment part just to accelerate. Counter 1 and 2 must be 0 9 or 1 9. What will happen? We are now in the run mode, let us say time run mode. So, what will happen after 0 9? This is counter 1 and 2. What do you expect? And the total time is, let us say 0 9 5 9 5 9. After this you expect 10 o'clock, right, after 9 hours and 15 minutes. So, as far as counter 1 is concerned, it should go to from 0 to 1 it should go. Let us not worry about all other counters, right. When we come to that counter part, right, there we will take that action for that particular counter. So, that means our design goal is only concentrating on a single counter, and that is what we are doing here. And if it is 0 9, then we need to advance it to 1 0. If it is 1 9, we need to advance it to 2 0. So, this counter 1 is concerned, 0 will go, be incremented just by 1. So, that is advance counter 1 will be done advance by 1 only when this condition is met. All other conditions are plain. Say 5 9 5 9 is still intact, this 5 9 5 9, that is all here in this. And another thing is, you have to advance hours time. This is the actual setting mode, this is running mode, this is setting mode. So, both have been clubbed. You have to necessarily club, because whenever you want to advance the counter 1, it may the advancing will take place both in normal running mode as well as while setting. So, we have to take this into account. So, here you see less than 2 means 0 or 1, that is why this has come, and other things are plain, it is straightforward equal to. So, that is how this statement is done. Is it clear to you? And I will just read out the comment for this. So, counter 1 to 2 0 9 or 1 9, counter 3 to is 5 9 5 9 in time run mode, or counter 1 equal to counter 1 2 is equal to 0 9 or 1 9 in hours time set mode is the condition for advancing this counter, and this is the pre increment for the counter 1. And next block is the actual, this is the very first block for the timer counter 1, and this is precisely the same as all the counters that we have been handling in all these lectures, right. And once again for reset the system, and reset when the terminal count is reached, or advance it to by 1. So, all these conditions we have just now defined previously, and this is precisely the same. So, similarly exactly the same thing will go on for all the counters. Now, I will expedite it a bit, because everything is going to be same except for minor variant which is particular for that particular counter. For example, advance reset counter 2, here exactly it will be same except the relevant thing is being taken here, and I will just read out the comment if there is any, right. And exactly same reset time, in time mode you need one sort of resetting, in set mode you need another set of conditions. Similarly, this is only to reduce the logic into, rather than putting a single logic in a long sentence, we have just bifurcated this. And here it is nothing other than reset counter to time here and set here. It means time mode and set mode, that is what it means. So, we are ORing either this condition taking place or this condition taking place, then also you need to reset counter, that is what it means. And in each also you have two such conditions. For example, there is one more OR here for this condition, and that is 0 9 or 1 9 condition or 2 3 condition, depending upon whether it is in advance hours mode, right. This is common anyway, advance reset counter here, and whether it is counter 1 2 or this, then also you need only to reset. So, this is common anyway. Note that bracket starts here and ends here, right, and this or this expression, and then finally this. Okay. Is there any problem in the brackets? Hopefully so. Then we need to set when this condition is satisfied, advance hours time, and this condition, or again precisely the same condition. That is what we have already seen, and I do not have to read the comments because I have already explained that. So, next is advance counter 2, which will take place, this also we have just now seen, either advance reset counter 2 is 1 or advance timer is 1, then only you need to advance counter 2, and other conditions are implied since reset counter 2 has a higher priority than advance counter 2. So, counter 1 to 2 is 0 through 18 for all this except 09 or 20 to 22. Of course, with the counter 3 to 6 must be 5959, and this is the precondition for incrementing this particular counter, and this is the pre-increment, and positive edge of the clock we need to do all this. Once again it is precisely the same, reset and terminal count reset, then advance, and similar is the case for resetting counter 3, and these are all the condition. I think I will leave it as an exercise for you to reason out. I will just read out the comments. Counter 3 to 6 must be 5959. We are now at the counter 2, that means this is counter 3. So, prior to this, right, and for advance count we need to have the counter 3 and 4 3 must be 0 to 4, right, and counter 1 and 2 is already exhausted. Now on 3 we are in. If it is 0 to 4, then only we need to advance, because this will go right up to 595 up to that. So, the other digits must be 959, and this is the pre-increment, and this is the usual block as we have seen before, reset once again advance here, and for counter 4 is precisely the same. Now, you notice that logic keeps on reducing because we are have to keep track of less and less number of digits on the right only. So, here the condition is 959 from counter 4 to counter 6, 4, 5, 6, only 3 are there, and that is for reset, and this is for advance, and this comment is again same 0 to 8, and then counter 5, 6 must be 59, and only then we need to advance, and this is again pre-increment for counter 4, and again counter realization using this block, and reset condition and then advance condition. So, is the case for counter 5. Counter 5 once again reset counter 5 is there, and counter 5, 6 must be 59. Now, you see it is much simpler. The very first thing was the worst among the lot, lots of logic was involved. Now, it is easing out. Advance counter 5 here, right, and here it is 0 to 4, and counter 6 alone need to be 9, and once again for counter 5 realization pre-incrementing, and then the block for the counter 5 and with the next assigned here, and finally for the counter 6, and this is the simplest of all the lot, and the condition is counter 6 equal to 9, and advance is 0 to 8 condition, and again pre-increment and the actual realization of the counter 6 here. So, this completes the running time as such, and next is stopwatch implementation. We need to, how do you implement the stopwatch is precisely the same, except that we have to do tamper with counter 7 through 12, that is what we have seen here, and if you are in up counting mode, term count reached up variable will be set for this condition. For example, all this terminal count reg 1 through reg 6, when it is equal to the respective counter running counter, and if start stop is in start mode here, and down up is in up mode. So, and set stopwatch is not equal to 1. Whenever it is not in set stopwatch, then only the up counter should run. It must run only in run all other modes other than the set stopwatch mode, and it should also be in up mode, because what we want is up counter basically. So, this is the when the terminal count match has been found is sensed only by this, right, and it naturally you should have started the button, push the button for starting, that is what is stored here, and terminal count reach down is exact counterpart for down counter. So for this RSD is the one which will be explained now. For counter 7 for all this condition you can just have a look, and let us go into the next one is this is for the condition for this must be all must be 0 because down counting, right. If all of them are 0, you notice that all the counters are 0, then it will stop, as you have witnessed a demo already. And when it is 0 0 0 after the stopwatch 50 minutes you have already seen, when it becomes 0 0 it rang a buzzer and stopped, froze the display to all zeros. That is precisely being done because of this statement, right. And timer out, that is also displayed. Had you noticed in a bar graph there on the display earlier, one central bar will be switched on, and that is also available for outside world. We can fire a rocket by using that output, and that is precisely here. And timer out. So timer count, when it reaches up, that's a match is found, either that is found or down count match is found, then also only for these two conditions you need to set the timer out. So that is the thing. So that will give you the timed output. And RSD is we have already seen, which means stopwatch, it is not in set stopwatch mode and it is in down mode, right, and run stopwatch down. So that is the abbreviation I have followed for RSD, and it must also be in start mode, right. And counter 7 reg is the stopwatch's most significant digit. This reset or advance only in the run stopwatch mode of operation. For down counting, counter 7 through 12 regs are used, whereas for up counting, term count reg 1 to reg 6 are used for presetting. This is only for presetting we use this terminal count reg 1 through reg 6, right. And counter 7 through 12 are running counters for both up and down counting. If this is clear, and everything else will be understood readily. And based on that we see some more here. Once again resetting, advancing counters and so on. So for example, counter 7 you want to 7 is the hours MSD. So you need to, I am going to read only the comment hereafter, because all the other nomenclature is exactly the same we have followed earlier. And counter must be reset in setup mode, and counter 7 8 must be 2 3 are the conditions for resetting the counter in set down counter mode. This is a down counting mode and we are in set. So when that happens, when we want to reset, that counter 7 is put here, this is the condition, and the condition for advancing this same counter is here. Counter 7 through 12 must be 0 9 5 9 5 9 or 1 9 here are the conditions for pre-incrementing the counter. So you can see exactly the same that we have argument we have followed for counter 1, right, earlier for time. Now we are talking with respect to stopwatch, and pre-increment as usual have here, and in addition to that we also need a decrement counter 7 because it may go into down count mode. So this is what is for down count we have already seen, and when the counter 9, 8, 9, 10 and 11 and 12 all of them are zeros, right. It is a decrementing. When this happens, what should you do? And counter 7 must be greater than 0, then only, and counter 7 must be less or equal to 2, and it should also be 1 second. Only then you take this decision, right. Only then you decrement the counter 7. Are you clear about this? Is it clear to you? That is the condition when you should decrement, when you should preset, when you should advance, when you should reset and or decrement, etc. You will have to do appropriately. So this is the core of the working, and you need to pre-decrement here. That is what we are doing here, and this is the counter 7 block here. Once again it is exactly same, except that reset has been taken here, advance and then decrement here, and that's for counter 7, and counter 8 exactly similar, except that resetting will be different condition, and so is the case for stopwatch also you have to take into account. That is the condition for this, and counter 8 reset is required, and these are all the condition that similarly for counter 8, then advancing the counter 8 when it is in set mode, when it is in stopwatch mode, all these are exactly same. So I am not going into the details, and I will read out only the comments if any, and if it is exactly same as before I do not have to do that, and this is also exactly same, counter 78 is 0 to 18 or 20 to 22, and other counters must be 5959. These are all the preconditions for incrementing the counter, and counter 8 is incremented and decrement conditions are here for 0 to 9, then 11 to 19 or 21 to 23, and all other counters must be 0. This is the condition for decrementing the counter and pre-decrement here, and this is the block for actual decrement here, exactly same, and the preset happens here when it is 9. So we are 7 8, this is second digit, so you remember that it is it 9, 7 and 8, right. So what should be this condition, preset condition? It is this here, right. This is the preset condition. If it is 1 0 or 2 0, then what should you do for counter 8? 7 8, right. 7, this is 8. So what should you do? You should, we are in decrement mode, right. So this means decrement mode. Automatically it should go to 0 must go to 9. So you can't reset, you will have to preset. That's why preset has been used, right. So we will continue from this point onwards, and this is what we have seen up to counter 8 in the stopwatch mode. We will have to start looking into from counter 9, which we will do in the next lecture. Thank you.